Testing 1, 2, 3, this is Mr. Longo, and we are going to simplify some radicals in this video. Heads up, this is more challenging, so if you don't know how to simplify a simple little radical, this video is not going to work out for you. You need to know how to do the basics before you jump into this video. For example, we should remember that the square root of x to the 8th is x to the 4th power. But the square root of x to the 9th would be x to the 4th root x because we have an extra x that we can't take the square root of. Okay? So, just make sure you are aware how to do that. Now, let's jump into some of the fun stuff. Now, when you're working with radicals, often there are ways to do more than one thing. Now, I'm going to do this one in a way that I would recommend because I think it's going to be the easiest way. And when you have a whole bunch of stuff inside of a radical, including a denominator, most of the time it's a lot easier to work with it if you simplify that fraction first. For example, we have a negative 7 over 14. Neither one of those are perfect squares, so we're just going to divide that, and that's just going to give you a negative 1/2. And the next thing we see is we have 4 a's on top but 5 a's on the bottom. And we learned back in Algebra 1 that we can just cancel. So if we have 4 a's on top and 5 in the bottom, they play tug of war and you're left with just 1. If we were to cancel 4 off of each the top and bottom. So we're left with just an a. Now the b to the 5th power and the c squared are going nowhere. So those are just going to stay right there. Now, one thing I've mentioned many times is a lot of times it's a lot easier to split a big fraction radical into a radical for the top and a radical for the bottom, or your numerator and denominator. So the first thing I'm going to do for the top is take the square root of a negative 1, which I know is I. I know that the square root of b to the 5th power is going to be b squared with an extra b left over, and the square root of c squared is just c. So I'm done simplifying the top. Now I'm going to go work on the bottom. I can't take the square root of 2, and I can't take the square root of a. So I'm stuck. There's nothing else I can do right now. Except there's a rule that says we're not allowed to have radicals in the denominator. Again, something I really don't agree with anymore because we have, calculators that can work with square roots in the denominator, but until that goes away, we're going to keep doing it. So how would you get rid of a radical in a denominator? What you do is you multiply the top and bottom by your denominator. By doing that, it's just an extra step, but we're multiplying by 1. Remember, 2 over 2 is 1. X over x is 1. So the square root of 2a over the square root of 2a is 1. And anything times 1 is itself. So we really didn't do anything too crazy here. But what it's going to do for us is eliminate our radical in the denominator. Because the square root of b times the square root of 2a would just give us the square root of 2ab. And then we would still have our other variables out front, so we would have our b squared ci. I typically like to write the I right in front of the radical over, and we would have the square root of 2a times the square root of 2a, which would give us the square root of 4a squared. And the square root of 4 would give us a 2, and the square root of a squared will give us an a. And now we are done with this example because there's nothing else we can do. Sometimes you would have like numbers that could cancel. Like if you had a 4 out here, we would do 4 divided by 2 and we would have 2. So there are other things that we can do in certain situations, but for this problem, we're done. And yes, you are supposed to leave it that ugly of an answer because there's nothing else we can do. In example number 2. Again, there are multiple ways to do this. You could just straight up tell yourself that you do not like that square root of 20 in the denominator, so you're just going to multiply it to the top and bottom. But something that might be a little bit easier to do is reduce these, because remember, The square root of 10 over the square root of 20 is the same as the square root of 10 over 20, which is just the square root of 1/2 because they simplify or reduce. So we can change this to 2 times the square root of 1 over I square root of 2. But obviously we know the square root of 1 is 1, so we're done with that step. So we have 2 over I root 2. And we have two issues right now. We have an I in the denominator, which is not allowed, and we have a square root in the denominator that is not allowed. But luckily, we can make them both go away by multiplying the top and bottom by, you guessed it, the denominator, I root 2. And by doing that, we have 2 times I, which is 2I root 2 in the numerator, and our denominator would be I times I is I squared, and root 2 times root 2 is root 4. And the last time I checked, the square root of 4 is 2, and I squared is a negative 1, so that would give us 2I root 2 over negative 2. Because again, I squared is a negative 1, square root of 4 is a 2. And here's an example where you can continue simplifying. We have 2 on top, 2 on the bottom. There's no pluses or minuses to worry about, so we can just cancel those guys. So we would just have a negative I root 2 when you're done. And when you're working with those, just make sure you are just doing proper steps. Don't make up any new math. It's got to be the same thing that you're multiplying on the top and bottom, because that is multiplying by 1. Here's our last example for this video. Here is an example where we have a plus or a minus in the denominator. So we have to go back to another video that talked about a complex conjugate. Because we have an I and a radical in the denominator that is attached to a number with a plus or a minus sign, we can't multiply the top and bottom by the denominator. You have to multiply the top and bottom by the complex conjugate, because remember, that's what makes those middle two, when you're combining like terms, disappear, because they'll cancel each other out because one's positive and one's negative. So we would just distribute the 5 on top, and that would give us 15 minus 5I root 5. And then the denominator we're going to have to FOIL. So we would have 3 times 3, which is 9. And then we would have 3 times a negative I root 5, which would give us a negative 3I root 5. And then we would have I root 5 times 3, which is going to give us our positive 3I root 5. And then an I root 5 times a negative I root 5 would end up giving us a negative I squared root 25. Okay, and that's a big, nasty looking denominator. So we're going to obviously cancel these guys because they're just opposites. And that will give us a 9. And we have a I squared, so that's a negative 1. And the square root of 25 is 5. So minus a negative 5 is going to give us a plus 5. So our denominator is going to end up being 14. So that would just give us 15 minus 5I root 5 all over 14. Now, from here, you could always check to see if something can be reduced. A little trick is to actually split them, and it's absolutely not necessary in this situation, but I just wanted to show you a little trick just in case. You can always split the numerator. You can never split a denominator, but you can split a numerator with the same denominator and see if something can simplify that way, but in this way they still can't, so it doesn't matter. Okay, so that's it for this video. Almost 10 minutes just to talk about 3 questions because, you know, these things are fairly complex. All right, y'all, this is Longo, and I'm out. See you, bye.